This is GCSE Further Maths Pure. We are on Chapter 5 Differentiation, and this is our example 3 then for differentiation involving optimization. So this is a tough one. A metal container is made in the form of a closed cylinder, volume 125 pi centimeters cubed. Find the minimum area of metal needed. So it's the surface area of the metal. Let h be the height of the cylinder and r be the radius of the circle. So we have ourselves a wee cylinder here. This here is h, and this here then is r, and we know that the volume is 125 pi centimeters cubed. That's not the thing we're differentiating, it's the surface area. So we are asked for the minimum surface area, so we need to find the surface area. So hopefully you can picture this. I'll do a wee diagram out. Say you fold this out. It's a tin, so it's like a tin of beans or something. So there's two circles. That's pi r squared. And then if you roll that out, you get like a rectangle. If you roll out the curved bit, hopefully that makes sense. This here is h, and this here. So what's that going to be? That's going to be the same then as the circumference of this circle. So that then would be 2 pi r. So our surface area is going to be two circles, so it's 2 pi r squared plus this times this plus 2 pi r h. Again, we have an h and an r in here, so we can't differentiate. There's two variables or two unknowns. We can't differentiate. We do know though that the volume is 125 pi. We also know the volume is pi r squared h. That would be the volume of this here. Obviously pi r squared or area then times per height. So 125 pi is pi r squared h. Dividing through by pi. 125 is r squared h, and that means h, if we divide by the r squared, is 125 over r squared. So we can now exchange our h in this formula here for 125 over r squared, and then we have one variable, so we can differentiate. Still a tough question. So our surface area is 2 pi r squared plus 2 pi r h, which is 2 pi r squared plus 2 pi r upon 125 over r squared. So our surface area is 2 pi r squared. Can you see how it's going to tidy up? It's 2 times 125, and then there's an r on the top and an r on the bottom, so it's going to be, let me see, 250 pi r over r squared. So that r cancels there with that r, and we end up, if we're going to try and differentiate, I'm going to bring the r up to the top and put it to the power minus 1. Hope that's okay. Surface area is 2 pi r squared plus 250 pi r to the minus 1. We're trying to minimize the surface area, so we are going to differentiate this. So dSA by dr. So remember, you just take the 2 pi really as a number, so the 2 times the 2 pi is going to give me 4 pi. Take away 1 from the power, we're going to get r. Minus 1, so minus 250 pi r, take away 1 from the power to the minus 2. At our turning point, dSA by dr equals 0. So that means 0 equals 4 pi r minus 250 pi over r squared. I hope you see what I've done there. That makes sense. I'm going to multiply through them by r squared. So I would have 0 equals 4 pi r cubed. Take away 250 pi. I'm then going to take this over the other side. So we're trying to get the r on its own. So it's 4 pi r cubed equals 250 pi. Pi's are going to cancel here. Divide this by 4, you get 62.5, which isn't a lovely number, but that's okay. 62.5, and r then is going to be 3.969. We want to show that this is a minimum. So we need to find D2SA. It's getting complicated. D2SA by dr squared. So what are we going to differentiate again? We're going to differentiate this bit again. So the r bit, remember, is our variable, so that's going to change into 4 pi. You can see that okay. Minus 2 times the minus 250 plus sorry, I'm just making sure, yeah, minus 500, I think. Pi r to the minus 3. Therefore, let's put that down again. There. D2SA over dr squared equals 4 pi plus 500 pi over r cubed. Since r is positive, then D2SA by dr squared is going to be greater than 0. There's no way, if I substitute 3.969 into that, I can't get a negative number out, so it's going to be a positive. I don't know what I get, but you know, it's not going to be a negative. Therefore, it is a minimum. So we're in good shape. We need then the minimum. Let's somebody do that over here. We need minimum surface area, and so we will use then whatever formula we have for surface area. Let's go for this one here with the r's cancelled out, and we just substitute then our 3.969 into it. So our surface area is 2 pi r squared plus 250 over r. So substituting in our 3.969, 2 pi 3.969 squared plus 250 over 3.969. Again, if you play around with that on your calculator, you will get a surface area which is equal to 296.862. We're going for 3 significant figures. We'll go for 297, and that's centimeters squared, and that then is the 3 significant